This is the activity on lines of symmetry. The objective of this activity is to identify and draw the lines of symmetry in different shapes and patterns and understand the properties of these lines. Let's understand the concept behind this activity first. If you take a known shape like the shape of a square, if I draw a square here and now I want to divide this square into two parts with a line such that the two parts should be exactly identical. So I can draw a horizontal line passing exactly midway through this square. So the two parts above this line and below this line are going to be exactly equal or mirror images of each other. And therefore, this line which we have drawn is known as the line of symmetry. So, can we draw some more lines of symmetry in a square? The same could have been done by drawing a vertical line like this, in which the square gets divided into two parts which are identical like this. Similar thing can be done using the diagonal like this. Again, the two parts, one on the top and one at the bottom of this line, they will be exactly identical, and we can draw another line using the other diagonal. All these lines are known as the lines of symmetry in case of a square. So as you can see, I have drawn 4 lines of symmetry here. I don't think you can find a fifth line of symmetry in case of a square. Likewise, if you have a rectangle, we can draw some lines of symmetry in case of a rectangle also. Can we draw a vertical line like this, which divides the rectangle into two equal halves? Obviously, yes. And a horizontal line that also divides the rectangle into two equal halves. But the diagonals are not going to be the lines of symmetry here. Try to find out a reason for that. A rectangle has only two lines of symmetry. Now suppose you have a scalene triangle where all the three sides are of different measure. Now I'm drawing a random scalene triangle here. Can you tell me how many lines of symmetry will this have? This has 0 lines of symmetry. That means you can't draw a line across which the figure is symmetrical. But if this triangle is a specific type of triangle, like an equilateral triangle having all the three sides as equal, then we can draw some lines of symmetry. The line like this, the line like this, and the line like this. All these three lines are the lines of symmetry in case of an equilateral triangle. So there are 3 lines of symmetry. Now the most important part of this activity is the shape of a circle. In case of a circle, can you estimate how many lines of symmetry does it have? Surprisingly, this shape has infinite lines of symmetry. So you can keep on drawing a line passing through the center of the circle. You will get a different line of symmetry, and therefore a circle is the only shape which has infinite lines of symmetry. Having understood the concept behind this activity, let's now see what material is required to perform the activity. So we need some sheets of paper, a scissor for cutting work, a ruler, a mirror for checking whether the shapes are symmetrical or not. We need colored pencils or markers. We need printouts, or you can draw it yourself also, the various geometric shapes for which the activity has to be performed. So let's now see how we can perform this activity. So in this activity on lines of symmetry, let's first pick up the shape of a square.
So we will write square in the observation table. Now if I fold this square along its side like this, you will find that these two parts or the flaps are exactly the same, and therefore if I draw a line like this line becomes a line of symmetry because the two parts are exactly the same. If I fold it the other way around here like this, again the two parts are going to be exactly the same, and so we will have another line of symmetry like this. Does square have any other line of symmetry? Yes. If I fold it along the diagonal like this, see, I have two triangles which are exactly resembling each other, right? And so this part or this line which I am drawing right now, this also becomes a line of symmetry. So I have another line along the other diagonal when I fold it like this, and so a square will have these four lines of symmetry which I have drawn on this figure. So the number of lines of symmetry are 4, and symmetry observed or not, you have to write yes, symmetry is observed. Likewise, if you pick up a rectangle, see, I have the cutout of a rectangle. If you fold it along the length, you have two identical rectangles. If you fold it along the width like this, you have another two identical rectangles. So these two creases which are formed on this, they are the lines of symmetry. But a rectangle has only these two lines of symmetry. If you fold it along the diagonal, they are not going to overlap, as you can see like this. You can verify the two mirror images using the plane mirror also. If you keep a mirror as the line of symmetry, on both sides of the mirror you will have identical image. And so the rectangle has only two lines of symmetry as seen here, and symmetry is observed. If you have a scalene triangle, so I am using a scalene triangle now in which the three sides are different. So you can see here the cutout of a scalene triangle, all the three sides are of different length. You try to fold it along the length, along any side or along any angle, you will find that the two parts will never be equal, and therefore the number of lines of symmetry in case of a scalene triangle is 0, and there is no symmetry observed. Likewise, if you convert this scalene triangle to an equilateral triangle, so I'll write here equilateral triangle. Now, since all the three sides are equal, if you fold it along one side, the two parts will exactly be the same, and so you will have one line of symmetry like this, another line of symmetry like this, and another line of symmetry like this. So an equilateral triangle has three lines of symmetry, and yes, symmetry is observed. Likewise, you can go on and change this shape. If you have a circle, this is most interesting part of the activity. The center of the circle is here. Let's label this as O. Now you fold it along O. So O has to be a part of your fold. You will find that the circle has two equal parts and it has infinite lines of symmetry. And yes, symmetry is observed. How do you draw those infinite lines? You can keep on drawing any diameter and that will be a line of symmetry. So how many diameters can you draw? You can draw infinite diameters. And finally, if you have a object like a star, so this is a uniform star, these all sides are same length. The number of vertex are 5 in this case, right? So this star, 5 vertex star, has 5 lines of symmetry, and yes, symmetry is observed. There are so many examples where symmetry is not observed and symmetry is observed. If you see this divider, it has a line of symmetry here because the two parts across the center become the same. Likewise, if you have a protractor, if you draw a vertical line passing through this point, 0 point, then the protractor will be divided into two equal halves, it has a line of symmetry. But if you pick up a calculator, this doesn't have a line of symmetry because of its shape. And that completes our activity on finding the lines of symmetry.